ทดสอบทดสอบทดสอบทดสอบทดสอบทดสอบทดสอบทดสอบทดสอบทดสอบสองกับสาม
เคหนึ่งสองสาม
Ohayo gozaimasu. สวัสดีครับ
Good morning, everyone. On behalf of Princess Julapon High School student, we are delighted to welcome you to the Thailand-Japan Student ICT Fair 2024.
We are honored to have students from both Thailand and Japan who have traveled all the way to Stun to present and share the amazing science project with us today.
This event is a unique opportunity to exchange ideas, foster collaboration, and celebrate innovation. We hope you are as excited as we are to dive into the inspiring work you have all brought to this event.
Before we begin, we would like to introduce our esteemed lecturers who have joined us today. They are leaders in their respective fields and are here to guide, evaluate, and provide valuable feedback on the projects. First, Associate Professor Dr. Kisari Shaotiang from Prince of Songkhla University.
And Dr. Napat Kaopiban from Thaksin University. It's an honor to have such a distinguished panel with us.
This presentation room, Smart Classroom 1, will focus on the fascinating topic of artificial intelligence and machine learning.
Artificial and machine learning are shaping the future, revolutionizing how we work, learn, and interact with the world around us, from enhancing healthcare to enabling self-driving cars. This field opens endless possibility for solving real-world problems and advancing technology.
We are excited to see how your projects explore this cutting-edge topic. Without further ado, let's begin with the first team.
Our first team is come from Mahidol Vichyanustan School, and they will be presenting their project titled Quantum Enhanced Deep Learning for Predicting. Please join us in welcoming them to the stage with a big round of applause.
Test เริ่มได้เลยไหมครับ Good morning everyone. We are from Mahidol Vichyanustan School and we proud to present our project Quantum Enhanced Deep Learning for Predicting PCSK9 NRC1 Inhibitor Bioactivity, a novel approach toward coronary artery disease therapy. And okay, next. Coronary artery disease or CAD was the cause of 1 in 3 deaths in worldwide, and the cause of it is protein that's called PCSK9 or NAC1, and it has duty to lower LDL receptor in our body and raising blood cholesterol level. So if we have too much PCSK9, it can cause coronary artery disease, and we try to developing a deep learning model that can predict PAC50 or the concentration of the drugs that can reduce the PCSK9 around 50%. And we found the problem that PCSK9 or NARC1 have very small data set, have just around 2,000 data points, but in the field of drug discovery, we require around 20 to 1,000 points, but we have just 2,000 points, so we try to developing a new deep learning model that can predict with small data set by combining two different data types such as molecular structure and homolumo or energy level of its orbital, and it's what the energy that show the potential of the binding between drugs and proteins. And the next is methodology. We start with data collection. We collect molecular structures and PAC50 from the dataset, and next we cluster similar molecular structure and turn smiles into molecular fingerprints and calculate for homolumo or quantum energy by using Gaussian zeroline. And next one, we prepare compare the correlation between the energy level of drugs and PAC50 between similar and dissimilar molecular structure. And the last one, we built a multi-input deep learning model by combining two different deep learning such as convolutional neural network and multi-layer perceptron. For convolutional, we using SMILES or molecular structure as input, and multi-layer perceptron we use homolomo data set, and the last layer we apply attention mechanism to predict with the small data set.
Okay, so next is our finding on the energy level of drug and the PAC50 correlation test. The graph indicates the relationship between the energy level and the PAC50. As you can see from the gray bar, it indicates a direct relationship between a HOMO energy and the PAC50, while the other is LUMO, and the energy gap has an inverse relationship to the PAC50. And we also discovered that the relationship between the energy level and the PAC50 was strong across a group of the molecule with similar structure, but it's weaker across the molecule with the diverse structure. So we conclude that the energy level depends on its structure, and it tends to be high relationship in the group of similar structure molecules. So based on this discovery, we used the energy level into our multi-input model to improve its model efficiency. And after we test the model efficiency, we discovered that the multi-input model has higher efficiency than the CNN and the machine learning model, with a square value of 0.8105 and a mean square error value of 0.4629. And let's look to the learning curve of each model. As you can see from the CNN learning curve, the blue line indicates the efficiency of the model on the training dataset, and the orange line indicates the efficiency of the model on the validation dataset. You can see the disparity between these two lines, which indicate that the CNN model has the overfitting in the model, while the learning curve on the multi-input model, this two lines has differences less than the CNN one, which show that the multi-inputs had the potential to reduce the overfitting in the model. And in conclusion, after we finding that the energy level of the molecule has some relationship to the PAC50 of the molecule, we use it in our model, in the multi-input model, and it tends to be higher efficiency than the CNN model and the machine learning model. And we discovered that the multi-input model has the potential to reduce its overfitting, and it also has the it can be adapted in the new disease with the small data set. As you know that in the discovery process, we need high amount of molecule, and we will lessen the number of molecule by scope at PAC50. And with this approach of multi-input model, we can use this to reduce the time and the budget needed in the drug discovery process. And we also develop MarketCat, which is the web application that make it easier for user to access it from anywhere. And here is our prototype of the model. First, you can go to the prediction page, and okay, the video. So in the web application, you can input SMILE and the energy level data, and it will output you a PAC50 values. Okay. So. Okay. Okay, so never mind. So, and here is our references. Thank you for your attention.
Next, let's go to Q&A session.
It's a difficult topic for us, I think, because we are not the expert in bio or something like that.
Yeah.
Okay. But I have question about for number page number 4, please.
Yes.
model structure right
Yes.
Okay.
คือว่าหน้ามันไม่ไปนะครับ
พูดไปก่อนก็ได้
ก็ what's your question
Question about for, I remember for data collection, you collect from 3 data sets.
database
Yeah.
yes
Yes, for 3 data sets, right?
Yes.
Why? Because it's different from the other.
database is from the laboratory where
From slide number 4, please.
หน้าต่อไป
Next slide, please.
หน้านี้ครับ
Yes, this one, yes. For data collection, why you have CHENVL, pub chain, or something like that?
because the PCSK9 or NERC1 structure data is from the laboratory where the lab that collect the data from lab and he didn't have the same data to ขอเป็นภาษาไทยได้ไหม
You mean because each data set is different data,
yes but
No.
same field,
Yes.
but the same attribute?
Yeah. But we need to gather a lot of molecule as possible, as much as possible. So in each database, they have like molecule and others property of molecules that the same property, and we filtrate the data later. That only the data that we use.
But it's
So.
not complicated data, right? It's not duplicate data.
If duplicate, we select only one. You see?
Only one, but
Yeah.
it have duplicate or no duplicate in your data set.
it's duplicate we need to drop it out we collect
Yeah.
just one
Yep.
they're not duplicate
How many you drop out? Is a lot or is only a little?
It's a lot. At first, we found like all the data sets around 10,000, and after we drop out is 400 because sometimes the data is not like completed. Yeah.
And for your data preparation, what tool that you use?
Preparation.
Yes, are you coding only coding
Ah.
or you use tool?
it's just Python
Is Python. So yeah.
Yes. But this we didn't use Python because it's a homolomo energy where we need to run with Gaussian 09W and we need to run it on school server.
Only one question.
Okay. Okay.
One question and suggestion. Why you choose the CNN and NLP combined?
CNN we use with the molecular structure because CNN can pull out the base คือว่ามันเหมือนกับว่ามันดึงแบบข้อมูลที่มันเป็นลักษณะเฉพาะออกมาได้ ผมนึกคำไม่ทันแล้ว
So the molecular fingerprint has a sequence. It's a sequence structure. So CNN works well with the molecular fingerprints. Yes, and for the energy level data, we don't want we don't want the model to be too complicated, so it will not overfitting. So we choose the most basic one. Yeah. Okay.
Next, we will proceed to the certification.
But we adjust the percentage. Yeah.
May I invite Associate Professor Dr. Kisiri Shotjiang to give the certification to the student. Please welcome.
Thank you, Mahjong Wittianusson School, for an excellent presentation. Your work was both inspiring and thought-provoking. Now, let's welcome our next team from Princess Julaponsan High School, Chonburi, who will be presenting on the topic of developing a model for the recycling. Let's give them a warm round of applause.
Yes. Okay. Today, I will present about my project, developing a model for
recyclable waste using recyclable waste classification using audio objective.
The objective of the project is to promote new type of waste separation using sound by developing a machine learning model that can classify plastic bottle, can and glass bottle. The benefit of this project is the classify the sound of plastic bottle, can and the glass bottle, and grant an understanding of how machine learning.
Okay, our equipment and software using our hardware is using notebook, and software we use Jupyter Lab, and framework we use TensorFlow. I didn't put it here, sorry for. Our framework is first we have to study about relating project and research. After that, we use a microphone to record the sound of falling object, like plastic falling on the floor and can falling on the floor. About 19 sample, and after that put and 3 label, like can label, plastic label, and glass label. It's gonna be 270. After that, import file to the program Jupyter Lab, and after import to the Jupyter Lab, we have to convert the sound from wave file into the spectrogram. After we convert to the spectrogram, we have to convert to the NumPy array, because the framework requirement to input in NumPy array. After we have NumPy array, we put it to train about 10 epoch. After that, in training section, we writing a graph to know if it overfitting or not. But and this is example of our result when we drop down the object like can or plastic. The code will predict and show like predict waste type is can, but I didn't have sample it here because it's my fault. But okay, but this is performance about our model. We test it in real life about 50 times per type. Plastic 50 times. The accuracy is 50, and the bottle and the can is 46 of 50 accuracy, and the glass is about 46 of 50.
The conclusion of this project, the process we began with preparing a dataset consisting of 90 audio simple each of plastic bottle, can and the glass bottle. The model was training total 10 times, and after training we was test this model 50 times. Okay, sorry, 50 times, and overall the project have accuracy is 94%.
Thank you. We are finished.
This is a very interesting project that I think I have one more question to ask. Please, you go to the slide to show the architecture of your project.
Okay.
I heard that you are test with the sound of the button, 3 kind of button, like
3 types of waste is about plastic, can, and glass.
and glass, right?
Yes.
Okay. And when you test the those of button, is an empty button or is a something in the button?
For this result is empty bottle. All of them are empty. But when not in this, we already taste have a bottle of water have a half and half full. It can predict. I'm not really check it, but it can predict. But I didn't do about water in the can because when we taste it, it's gonna make it dirty. When we drop the water in the can will splash out. You understand, right? So we didn't taste it.
But in the real world,
Yes.
you need to detect the sound. You have to make the real development. Right?
Yes.
Yes, the empty version, half of button, or the full of the button, or three part, something like that. That I suggest you. Maybe you can make a next project to cover this topic.
Okay. And then you why you convert sound wave to spectrogram with numpy array or something like that?
First, when we record, I record into wave file.
Wave file.
If we use wave file to train, the accuracy will very low. I tested before; it's only about 60%, the accuracy overall. And after that, I try the new way. I searching internet and study it. They say we have to change to the numpy array. So I convert file to the numpy array first, and the accuracy will be 80%, something like that. But it's not that high. So I study again, and I new study. They say we have to convert to spectrogram first to stay the accuracy of the sound. If we use wave file change to the numpy, the audio file will be like press, and it will be less affection. So we have to convert to the spectrogram first to stay, and after that we have to change spectrogram to the numpy and use numpy to change.
Okay, good job because it's time up already. Again.
Okay, next we will proceed to the certification. Hello. May I invite Dr. Napaviban to give a certification? Hello.
Our next team comes from Princess Julapon Science High School, Nakhon Si Thammarat, with their project title, Development of Light Curve Classification. Let's give them a warm round of applause.
Test. Okay.
Good morning, everyone. My name is Panpepachani.
Hi, my name is Pakon Munchongcharan.
We from Princess Julapon Science High School, Nakhon Si Thammarat. Today, we're proud to present development of light curve classification model for wearable star using deep learning technique. Background of this project. Currently, there is a lot of space exploration. This leads to the development of space technology and discovery of new stars. However, have one type of the star, so it's hard to classify, which is wearable star. Classifying the wearable star requires a lot of time and high resource for analysis. This leads me to create this project to create and develop deep learning to classify the wearable star and to study the relationship between variable star and the like curve. And this method of the project, I import data set from the optical gravitational lensing experiment or OGEL. Next, I prepare data, I remove defective data and unnecessary data to categorize the type and subtype of the variable star and assign number to represent the star type. And the table shows the data value for each of the type of the variable star. If you see in the red box have less amount of data. So data is not balanced. I solve this problem with I randomly select 10,000 star from each class to balance the class population. And you see the async type. This async type have 366 data. This amount of data.
And after we random selected, we use the photometry data like curve to plot the graph in for every type of variable star. In x-axis of graph is the in time in Julian's day, and the y-axis of graph is brightness in magnitude. But also this is about the main type of variable star, but it have a large range, so we have to binding the data because we want to make all the data have the same number of groups. So we have binding the data, but we have some problem because in some field there is no value, so the field is empty. But we can replace the new value using the linear interpolation. Interpolate the value between no data point on the straight line. Join them and assume the transition between them is a straight line. And we use this equation. And after that, we have to data statistics to be used in creating and measuring the performance of deep learning. 70% for train, 20% for test, and 10% for variation. And this is about the deep learning workflow. But this is the main class, but the subclass is so many. We have to use the hierarchical technical. This technical involves building a main classification model and then connecting to the subclass model.
And the algorithm selection, we choose convolutional neural network algorithm or CNN. Why we choose CNN? CNN has the following advantage: is one, accurately analyze time series data; two, able to compare information; okay, and three, analyze data quickly. And how to test the performance of deep learning? We test performance in a confusion metric and everyone score. Everything look good, but if you see in the red highlight, is the SF in Taiwan variable star. SF in Taiwan variable star have less amount of data, so it reduce the accuracy of deep learning. Where? Okay, sorry. Conclusion of this project: from the development and creation of a variable star classification model using like curve relation with deep learning for type and subtype variable star. Using the convolutional neural network algorithm and hierarchical techniques to address data imbalance issue, and accuracy of 93% was achieved based on F1 score and confusion metric evaluation. However, for the SF variable star type, smaller amount of data compared to other type. Even after applying binding and pre-processing, still affect the performance of deep learning. Thank you for attention.
Yes, many data sets, right? I think a
Yes.
big data set.
Yes.
Okay. Why you have for the missing data or something like that? Why do you why do you replace it with linear, right?
Yes.
Yes. Why don't you remove it or something like that because you have many data set, the amount data set.
Sorry.
Can you see question again?
Okay. Because I see you have for the big number of data sets, right? Yes, and then you tell me it have something because it have something wrong because it's missing value.
Yes.
Yes, and then you replace it with linear something.
In this.
Why you don't remove it or drop out it? No. Back. Okay, this one.
Okay. I don't remove it because in binding the data, we want to make all the data have the same number of groups. But in this graph, it's plot like curve graph. It have a amount of data, but it have gap about it have gap and space about the between the data. So and after we binding the data, it have some problem because in the field is no value. Yeah. Yes, and we replace it with linear interpolation.
Okay, maybe go to the next slide, please.
Next slide.
Okay, you separate the data into three types of the data sets, right?
Yes.
The training, testing, and validation. And every class you have to separate in this ratio, right? Every class, right? All of the data, and you random select to the train or separate the class.
Yes.
Separate the class, right? Okay, individual class, and you separate in the train, test, and validate, right? And why you choose this ratio? Why you should train just 70%, why test 20%, something like that? Yeah.
Because this ratio is the best performance for train the deep learning. If we train lower than this, it make the deep learning have the less accuracy. And in we have three. If we data spacing in three parts, it had reduced the overfitting of AI.
And one thing you have to concern about the execution time too, okay? And you have to measure the how long they train the data because you have a lot of the data. Okay, one thing I suggest you to. Okay, thank you.
Thank you.
Next, we will proceed to the certification. May I invite Associate Professor Dr. Kisiri Shotjiang to give the certification to the student. Please welcome.
Thank you, Princess Sulaponsana High School, Nakhon Si Thammarat, for presenting such a fascinating concept. Your passion for the subject really shone through. Well done. Now, we have another team from Princess Sulaponsana High School, Nakhon Si Thammarat, with their project titled Automated Cocoa Garden Robot and Real-Time Cocoa Disease Analysis with CNN. Let's give them a big round of applause as they take the stage.
Test.
Test.
สวัสดีครับ Good morning, ladies and gentlemen, and my name is Chirapong Tawangel.
My name is Sukonimi. We are from Princess Julaporn Science School, Nakhon Simrat. Today, we're so proud to present Acrobat, an automated Gogo Garden robot and real-time Gogo disease analysis using CNN. Our advisor, Mr. Tapan Chukin and Ms. Kusalin Timano Singh.
Okay, first, we're gonna tell you why we do this project. Because in my province, Nakhon Simrat efforts are being made to promote cocoa as an economic crop that could generate over 4 billion baht in value. But growing cocoa is not as simple as we think because cocoa requires 1,500 to 2,000 millimeters of water per year. But in my country, Nakhon Simrat, my province, it's received around 2,200 to 2,400 millimeters of water per year, combined with increasingly higher temperature without the cause of the climate change. This has led an environment that supported the growth of fungi, where the cause of cocoa disease.
Typically, farmers manage infected cocoa pod by manually inspecting each tree in the farm. However, this method is time-consuming and labor-intensive. If diseased cocoa pods are not quickly managed, the disease will spread to other trees and it will cause a lot of damage to the farm.
Okay, eventually, a reduction in both the quality and quantity of cocoa product can lead a decline of farmer income. Wouldn't it be better if the farmer has an assistant that helps detect disease and improve the efficiency of crop management and prevention? So we proud to present the solution that took over 2 years to develop, and it's called Acrobat. Acrobat was built for following the purpose. The first one is a reduce damage from plant disease outbreaks and simplify farmer routine, and the last one is increase efficiency in crop management.
Okay, because our fault that we don't put the process in this slide because of limitation. I will briefly talk about the process of AI. We collect data from open source called Cocoa Disease Detection Computer Vision Project from ROFO. There are 4 classes including healthy, mirrored, blackpot, and fuzzy pot. But the fuzzy pot has less amount of data compared to other class. So we use an algorithm called data augmentation to increase the amount of data and balance it with other classes. So this is the result of a training AI model. You can see the confusion metric. It shows that AI can predict at about around up to 80%. And the right image shows the use case of cocoa disease decision at Tochai Farm in Nakhon Simrat. And the second one is web application for displaying farm view. It shows GPS location point and disease detection status. There are 2 modes for gardener to control robot. The first mode called manual mode. Gardener can freely control robot with controller buttons and direction buttons in web application. And the second mode called automatic mode. With setting GPS location point, gardener can create their own part of Acrobat in their farm. So this is really flexible for any farm. And the last one, I will show you the Acrobat testing video. But so this showcase of using web application. And gardener can control robot with the controller buttons. And in web application, it shows the farm view that combined with the AI prediction. Okay, so this is all of our journey of developing Acrobat. Thank you for your attention. ขอบคุณครับ
Okay, thank you for your presentation. This very interesting because my research project is also in the cocoa detection too. But I have one more question. Okay, why you make the robot to detect the cocoa disease? Why you don't use like the application, mobile application or something?
Because of like in cocoa farm, there are a lot of trees here, and if farmer like not like ca- only farmers can't predict can't detect all of the disease in the farm. So I think it's better that it's have the assistant to help the farmer to detect the cocoa disease and can get rid of them of the farm quickly.
Oh, okay. And what is the height of the cocoa tree that you can detect with the robot?
The camera can moving, so I think
It's about the 30 centimeter to the 80 centimeter of the high gimbals.
Okay. And how many class of disease that you can detect?
The disease has only 3 class for now. Yeah.
Only 3 class.
Yeah.
Okay. Thank you.
Okay, for only one question. Okay. Okay. When a cobot know this is this tree has something wrong. Okay. How do it work? Is that only capture and analyze and then notify or something?
We have the web application to like for displaying farm view. So when the Acrobot detect the cocoa disease, it will notice on the web application like in real time of web application like this.
Yes,
Yeah.
it can count amount of infected pot right here, but the disease.
It will
Yes,
show
yes, yes.
only how
Amount.
many plants like.
How many infected pots in the farm right here, the black pot and virid.
Okay, and one tree per one shot, or is move around the tree for find something wrong.
Move around because the cocoa is occur around the tree.
Okay, thank you.
Thank
you so much.
Next, we will proceed to the certification. May I invite Dr. Napat Kelhuban to give the certification to the students. Please welcome.
Thank you, Princess Julapon Silent High School, Nakhon Si Thammarat, for an engaging and well-organized presentation. Your innovative use of AI in agriculture is truly remarkable. Let's give them another round of applause. Our next team is from Fukushima Professional Fukushima High School, presenting their project title, Creating a Mahjong Hand Predicting Model Using a Diffusion Model. Please welcome them to the stage with a big round of applause.
Hello everyone. I'm Seiya Hosumi. I came from Fukushima Prefecture, Fukushima High School. I'd like to talk about creating a Mahjong hand prediction model using a diffusion model. The purpose of this study is to create an AI for Mahjong. Mahjong is a Chinese game. Mahjong has include randomness, and not all information is available on the board. Mahjong is underdeveloped for AI compared to Othello and chess. Next, explain basic Mahjong rules and terms. Mahjong is played by 4 players. Mahjong tiles consist of 37 types of tiles, and with 4 tiles each types. Mahjong's match proceed by taking a tile from more tiles and discarding tiles. The goal of this game is making a winning hand like this. Unnecessary tiles for players correct at the discarded tiles area, so player can make some prediction about from the discarded tiles area. This is a diffusion model image of this study. First, obtain the data of the Mahjong hand on the board. Second, data change to values and define it as a vector of magnitude 37. Third, increase and decrease the numerical values, and finally, the numerical values convey a standard normal distribution. Standard normal distribution is a random values with of average is width of average 37 is being 0. Fourth, reverse this process and predict original hand from random values connected to other Mahjong data. Train AI, create an AI and train it using a 10,000 and 100,000 data point. This is a hand example and output with 10,000 data and 100,000 data. Some prediction is successful, but I think accuracy is not high. This graph shows a loss value. Loss shows between prediction and actual hand. The loss is not decreasing, and I think the AI running is not successful. The failure of AI running can be attributed to the following factors. First, lack of running data. Second, problem of evaluation method. Mahjong's discarded tiles increase as round proceed. So easy to predict other players' hand as round proceed. So change the evaluation method and learn again. uh, for, and now yeah, sorry. Uh, Also, I yeah. Also, uh, I want also now AI predict perfect other player's hand, but this prediction is so difficult for AI, I think. So I try to predict temperate. Tempi is only one tile by making a winning hand. So it is easy to predict other players' hand completely. So I try to predict temperate. So thank you for listening.
Okay, thank you for your presentation because we don't have the knowledge about this game. Okay, and please go back to the preparation slides. I'm not sure. Please go back to the slide for your presentation. In your slide, go back. Yes, go back. Okay, this slide. I have one question. I would like to know how you transform the image or something like that, or your game, right? Your box, right? To the 0 and 1.0 or something. I would like to know how you are process this. Could you explain? Is it like the symbol, right? The symbol, right? It is the symbol of your Mahjong game, right? Mahjong. It is a symbol, right? That image.
That image.
Yeah. Huh?
Yes.
Yeah.
This is convert to the number.
To the number.
This.
Yeah. Yes.
If there this example, if one tiles are like one tiles so like this, 4 tiles for one, yeah. So
What the 0, 1, 2? What does this mean?
This is a vector number.
The order number of the symbol, right? Because you have three image, right? You have 37 image, right? 37, and this is like the order.
Yes. Yes. 37 box and yeah. One. Yeah.
The 1.00 and 0.25. What does it mean? Yeah.
0 is not include hand example.
Oh, okay, and nothing in this.
Thank you.
Next slide, please. Next slide. Next page.
Yeah.
Next page. Yes. How do you get for 10,000 data and 100,000 data? How do you collect data? You play it or you random from computer or something?
Random.
How do you collect this data?
Yeah.
Generate from computer, or you?
This how do you call?
Yeah.
Their data in internet called tenfold. Yeah. So I get the data from like this site. So yeah. 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 Yeah.
Oh, okay. It has data already in internet.
Yes. Yes.
Yes. Thank you.
Yeah. Thank you.
Next, we will proceed to the certification. May I invite Associate Professor Dr. Kitsiri Shotjang to give the certification to the students. Please welcome.
Thank you, Fukushima Prefecture of Fukushima High School, for bringing such a creative and well-executed idea. Your work is both unique and impressive. Great job! Next, we have a team from National Institute of Technology, Kosen Sendai College, presenting their project titled Research on AI Learning of Flight Patterns. Please give them a warm welcome to the stage.
Good morning, everyone. My name is Yusuha.
I am Hitoha.
We are Sendai Kosen students. We conducted two research to develop a system that fly automatically exterminate. Research one is detecting working fly, and research two is predicting flies position 1 second later.
We will explain problem. Fly and mosquitoes are familiar insects for us. However, they also carry many infectious diseases to humans. Therefore, we decided to develop a system that using AI to recognize flies and automatically exterminate them.
In this research, we used Euro. We will explain methods. Research one, the first step is data collection. We collected the data from the video. In this video, this is titled "Cat Game Gets That Fly on the Window." By capturing 10 frames per second, we used 200 frames for training and 100 frames for testing.
Second, we collected teacher data for Euro to run flies with using the attention to label image.
Third, we created the training model to compare the difference between the training results. So we included the number of training teacher data from 15 frames to 100 frames to 200 frames. Each training model are called TD15 and TD100 and TD200.
Next, research two methods. First, during the trajectory. We plotted the center coordinates during the trajectory. So, the points plotted every 2 seconds. Second, we calculated the velocity vector between points and predicted the fly position 1 second later.
Next result. This is research one result.
In this research, we succeed in detecting working fly.
We calculated actually by how many of the 10 frames for test correctly detect fly. The accuracy for each model is shown the figure. Even with 15 frames training, Euro detected fly 99% accurately. This is because the background is white and fly is relatively large. This graph is output by Euro. Left graph is shows the accuracy, and right graph shows bounding box error. Left graph is TD15 result, and right graph is TD200 graph. Both graphs shows TD200 is more accurate and stable more than TD15 results.
Please look at there 4 figures. These green dots are corrected fly position. So these red marks are predicted fly position. Their results show that using the velocity vector is difficult to predict flight position 1 second later.
Finally, here is what we learned from this research. Even with 15 frames of training, the accuracy was sufficient. This is because the background is white and fly is relatively large. Also, velocity vector alone were not accurate predictors. So other methods must be considered. In future research, we would like to develop a system that detects and exterminates the actual flying fly. Thank you for your attention.
Okay, thank you. Please go to the slide. You show the data sets, training and testing data. Please go to back. Okay. Next, back slides. Back, the back ones. Okay, this slide. Okay. I have one question to ask. You use the video for the training.
Yes.
To 100 frame and the testing 100 frame. It is the same data set, right?
Yes.
And for the testing data, you random 100 frame.
Yes.
For testing data, right? You random the frame, right?
Yes.
From you random 100 frame, right? From 200, right?
Right. Yes.
Okay. And your capture just 10 frame, right?
Yes.
Okay. And go to the next slide, please. Okay, you learn from YOLO. Next slide. Next slide. Okay. And why you are shoot 50 frame, 100 frame, and 200 frame to to test in your model? Why you shoot 50, 100, and 200?
This is because to compare the difference between training result.
Okay. Okay, thank you.
Thank you.
Okay. Okay, I have only two questions. Okay, for you tell 200 frame is the best, right?
Yes.
Yes. Okay. Have you ever tried for 300, 400 frame?
Sorry.
No.
Not training.
No, you only for 200 and then you tell is the best, right?
Yes.
Yes, yes. Okay. I confused to know. What is the benefits of this project? Why you monitor for the fly? What is the benefit? Why you do this project? Why do you conduct this project?
We to protecting people from infection disease.
Okay, but for the fly is in the box, right? That you capture video, right?
In this in future research, for instance, in future research, so we predicted we would like to predict flying fly. So and so exterminate automatically exterminate.
Okay, thank you.
Thank you.
Next, we will proceed to the certification. May I invite Dr. Napat Gaviban to certification to students. Please welcome.
Thank you, National Institute of Technology, Kosen Sendai College, for an inspiring idea. Your solution is both innovative and practical, and we are amazed by your dedication.
Ladies and gentlemen, now we will take a break and we will begin our session again at 9:45 a.m. for the Team Major University Senior High School.
See you at 9:45 a.m.
Thank you. Welcome back, everyone. Next, we have a team from Major University Senior High School presenting their project titled Development and Evaluation of an Attendance Management System. Please welcome them to the stage with a big round of applause.
Hello everyone, we are from Major University Senior High School. Our presentation is development and evaluation of an attendance management system using face recognition with machine learning. Let's begin. In our school, teachers visually check students' attendances when the bell rings. And they are recorded on a list like shown in this photo. To eliminate mistakes, we developed an automatic attendance management system. Here are some previous research examples. There is attendance management system using Felica or QR codes, such as student ID cards, which has a possibility of identify theft. Also, schools cannot install exclusive devices easily. There are three main requirements for this system in schools. First, easy to introduce, accuracy, and short processing time. Now I will give an overview of the app that we have created. The image captured by the webcam is sent to the server. And then the authenticated information is saved in a CSV format attendance list. And then those information are then sent back to the client.
Next, I will talk in detail about the face recognition section. The module used in this app is a face recognition based on DLEAP. In general, it has a high recognition accuracy even with a single piece of learning image. For this app, we trained 24 pre-approved faces, one per person, and extracted 128 hog features from each face. Hog features are also extracted from the test image acquired from the webcam at the time of attendance. We calculate the Euclidean distance, which is the difference between these features. As shown the formula below, the face with the shortest Euclidean distance is identified as the actual person. The following section describes experimental method. To evaluate the accuracy, we performed face recognition on 24 pre-approved students and calculated the false rejection rate. All 24 were recognized on 3 separate days. To evaluate the processing time, we measured the time when a quarter pixels of the test image was recognized. Face recognition was performed in the situation shown in this photo. The PC specs, software, and other versions as you see.
Next, I will talk about evaluation 1 reduced pixel. This is a graph of false recognition rate. This is original image recognition and reduced image recognition. Reduced image recognition was higher than original image recognition. And this is processing time per frame. So reduced image recognition was shorter than original image recognition, reduced about 0.09 seconds per one frame. Next, evaluation 2 frame in a row. So 2 frame in a row recognition, the time required, the twice time required. And force recognition rate was decreased, and original image and reduced image recognition was 2 frame in a row, so makes no difference. So these are requirements we showed at first. So about easy to introduce, so achieved by creating web app. About accuracy, no mistakes, current manager attendance was not achieved. There's slight of misidentification. About short processing time, so almost achieved by making the test image smaller. Now, in summary, as a point of innovation, the log can be deleted. So if misidentification, so we can delete it on table by right click. So recognize the largest face on this image and using hog features to calculate more right. As a point of improvement, shorten the processing time, test 3 frames in a row, and security measures. So about security, so future face future value is very important personal information. So we have to measure about security in the future. That's all for our presentation. Thank you for your attention.
Okay. Interesting topics. Okay, I have only 2 questions. Okay, can it scan in group or only one by one? If you have three students, and then you can only one scan.
This is 2 scan, and this is only 1 scan. And
2 scan is you mean two times 2 scan for one student or 2 students? I'm not sure for 2 frames in a row. What does this mean?
Okay, so 2 frames in a row means this. So first time is a capture image and the recognition. So the person and name into the variable, and next, so second time, so the capture image and recognition, so name is a variable, and this these 2 variable was same, so confirm the person.
Okay.
Yes.
For 2 times 2 scan for 1 student.
Yes.
Only 1 student. Okay.
Yes. Okay.
And this is, your application can scan in a group.
Yes, in a group.
In a group, I mean you have 3 students and then you capture and then student number A, B, C. No, it cannot or it can.
So student.
Only one by one. One student or only one student can scan.
Yes. So so small face or big face there is, so if the app recognizes small face, so the force recognition rate so increase, so the largest face, so the app recognize. Okay, thank you.
only question for me. Okay, that the I have the questions. For example, if this guy come again, and the record will update or just the same in the day, in the classroom or something.
Yes. So come to classroom and in so in front of PC stand and this recognize in morning.
In the morning, and then if he come in the afternoon, the record will update again, right?
Yes. So we can see this log so again. So okay.
okay. And one last question for me. Okay.
Yeah.
If the internet is lost or broken, your application can use or cannot use.
Internet?
Yes.
So at this application don't have to use internet. Yes. So we can test local environment. So we yes offline.
For offline.
Yes.
Okay. Thank you.
Yeah.
Next, we will proceed to the certification. May I invite Associate Professor Dr. Kisuri Shajiang to give the certification to the student. Please welcome.
Thank you, Merito University Senior High School, for such a well-explained and practical solution. Your work truly demonstrates the power of AI in solving real-world problems. Next, we have a team from Jilada School presenting their project title, Artificial Intelligence for 3D Asset Model. Please give them a warm welcome as they take the stage.
Hello everyone, we are from Chitalada School, and today we are going to give you a presentation about our project. It is Artificial Intelligence for 3D Asset Model Reconstruction from 2D Images. So as you can see from this graph, we can see that the gaming industry and other industries such as animation industry have been growing every year, and it is also predicted to grow it more further in the future. So as the gaming industry have been growing, the importance of 3D assets is also need to be recognized as well, because it is being used in many games. And because of that, 3D artists have been more increasing in demand lately, and there's not enough 3D artists as of now. So that's where our project comes into work. So in the current state, the artificial intelligence in this field can recreate many 2D art with only text or prompts. But as of now, there are not many new technologies about 3D generative AI. So as of now, artificial intelligence is not well enough to recreate 3D models. So our objective is to recreate 3D models from just using 2D images or cartoon style. So this is our framework. We start by gathering data. This is our the original dataset, which will include 3D models. We gather them from Sketchfab and rewrite. So next step, we have 3 tools. First one is the Blender scripting. We will gather the dataset and capture them in the 2D style image. And SV3D will guess that how does the back of the picture look like. And after SVTD recognize the back, we will use Open3D to create a point cloud data, which is like the location of the 3D images. So this is our result after using the Stable Video 3D. You can see the facial features is still not correct, like the eyes, the mouth, and the hands. So it will come to our next step.
Sorry. Okay, so after we have the 21 image in different view from the SV3D, and we have the point cloud data. So we're going to reconstruct the basic structure of the model. So we're going to use the 3D point regression model. Oops. Okay. So here's our 3D point regression model architecture. Let's walk through it. So we have the 21 images as input, and because of that, we're going to use MLP layer to extract the feature of those 21 images and stack it together. Then we're going to focus only on the main features using the attention layer, and then we're going to predict the basic structure, like where's the head, where's the hands. So yeah, this is the basic structure. Then we're going to reconstruct the dense point cloud, which is this one, using the GAN model. So GAN model is going to take the sparse point cloud, the basic structure. And because of that, that's why we're going to use the graph convolutional layers, because the point cloud data is not ordered data. And then we're going to use attention layer. The purpose is the same as before. And yeah, this is all of our GAN architecture. So because of that, there's no loss function that's suited for our method. So we're going to build our custom loss function from these 3 loss functions. Which first one is the chamfer distance loss. This is to measure how the predicted point cloud is in the correct position or not. The second one is the mean square error loss. This one will measure for the correct, we'll check that the color of the point cloud is correct or not. And the last one is the density regularization loss. This one, because if the model predicts that all the point cloud go to feet, it's still correct. So we're going to, we have to distribute all the point cloud across the model, so we can have full body point cloud. So yeah.
So here's our result. This is the original point cloud model, and we capture them only the front using the Blender API. So we got the 2D image, and after that we put into Stable Video 3D, and it will render the 3D model for us. And as you can see, as I have said before, the facial features and some of the aspect of the model is still not correct. So we just need to put them into another model of us to gather the point cloud data. And this is like the 3D dense point cloud data. And then we need to verify it again. So the final result will be the model with fully facial features that is correct.
But as you can see, in these images, you can see like there is some point cloud error here because of the in the 21 of our image, in the front view it's fine, but in the side view that's going to cause an error.
Okay, so and we have 5 models, and this is the reprojection loss. The lower the number, the better it gets, and we calculate them by comparing these two ground truth model and the model we gathered by using Open3D. So like for like 3.6 is like some facial features is not correct. 2.5 is very good. Maybe there's still some problems in the hand, but in conclusion, we can now find a solution to create 3D model far more easier than before. By just using these methods, we can lower the time creating those models by like from a week to like minutes. So our future plan is to increase the number of data sets, fine-tune the model, and maybe deploy the model on the website. And maybe we can make the model suit for like 2D pictures of humanoid beings or living creatures or maybe some other objects. So that's our future plan, and thank you for listening to our presentation today.
Okay, thank you for your presentation, and it's a very interesting project. Okay, and I have only one question. One 2D image, you have to collect 21 image per one 2D, right?
So for the 2D image, we gather the 3D ground truth, which is like the dataset of the model, and then we convert them into 2D image, only one 2D image. But the 21 image is the thing we gathered from this. This is the model we got from the stable video 3D. We capture them, cap 21 image of different angles, so we can use it into the so this one we capture them 21 image on every angle, and then we put it into another model for training.
We mean that our 21 image was generated by AI from only one front images.
Okay, from front one image.
One front
and
image.
AI generate to 21 image automatically.
Yes.
Right. Okay. Okay. I think if it's more than 21 images, may make high accuracy or not, something like that. But if your answer is automatically generated, okay. Okay.
It's possible to create more image, but it requires more time and computer power to generate them. So we only gathered only 21 image for the most accuracy and efficiency.
The pilot project.
Yeah.
Okay, thanks.
I would like to know if it's an animal image, is generated to 21 too, or is depend on what is this image, what type of this image?
We never used animal image dataset, but it's possible to gather around 21 image of them as well. We can set them manually by ourselves, like how many image do we want, depending on the power of the computer we got and how much time do we have.
Okay. I would like to go to 27 page, page number 27 or like that. No. So 26, please. Okay. For this image, is a one image or two image, three image, right?
This means the model it's not correct, sorry. This means the model and the reproduction loss of the model.
Oh, this is model number one?
Yes, model number one.
Okay, because I'm confused why is it made.
Oh, sorry.
Okay, thank you so much.
Yes, thank you.
Thank you.
Next, we will proceed to the certification. May I invite Dr. Napat Kaohiban to give the certification to the student. Please welcome.
Thank you, Chilada School, for your creative and well-executed projects. Your work in AI-based 3D modeling is truly groundbreaking. Congratulations! Next, we have a team from Princess Chulaponthan High School, Pisanulog, with their project titles, virtual HOO mobile application for Mangrove Durian. Please give them a big round of applause as they take the stage.
Good morning. My name is Shananya Pokjan.
And my name is Manachapon Gerchai.
We come from Princess Julapon Science High School, Pisnulok. Today we're gonna to present everyone about mobile application for Mahjong Durian LiveNet, assignment with knocking sound and deep learning, or you can call Hu application. In Thailand, Hu means ear. So we will introduce everyone to the king of food in Thailand is durian. Thai people they are eat durian with a different ripeness or different level ripeness. So the vendor they use a special stick like that, tap on the durian peel, and they use their ear to make prediction. But the only expert can know by listening to the knocking sound, and right now they are a failed expert, so it makes a limited for the durian market. But don't worry about it, we have developed the Hu application for classify LiveNet by knocking sound.
And this is an example for our application work. You can tapping on the durian peels and the application will record the sound. And you can listen. If the sound is clear, you can place this button and the application will display the result. For our objective, first, develop a model to classify ripeness of Mahjong Durian. Second, develop an application to classify the ripeness of Mahjong Durian. For data collection, we record knocking sound for mobile phone with iOS and Android with this stick in the durian shop in Pisnulok and Sukhothai, and we categorize the data sound for 4 types: raw, quick resolve, ripe, and other. Other in this is mean the sound from the
Sound of wind, yes, sound of car, sound of wind, yes. Because the durian shop are located the roadside.
And for our methodology, first develop a model. We will input a lot of knocking sound and then augmentation to increase the data. Use low pass filter to reduce noise. Segment knocking sound for one knocking sound per one file and convert that file to MEL and FCC spectrogram and connect it together like this picture and train with CNN. Next is develop an application. We use Flutter framework to coding for develop an application. In application, it can record knocking sound, send to the model in port 1, and display the result. For the result, in model, the raw has an average accuracy for 99.64%. The crisp resolve has an average accuracy for 99.03%. The ripe has an average accuracy for 99.78%. Other has an average accuracy for 99.25%. And the average accuracy for this model is 99.6%. And the application, when we test and compare with the vendors, is no statistically significant difference. Therefore, the application is effective enough in predicting the ripeness of Mahjong Durian ripeness and can function as a substitute for expert. And now I will show you how to use the application, you can place the button start to start the application, and then application will count down in 3 seconds. 3, 2, 1. Tap on the durian, peels, and bring your phone closest. And then application will show the sound, and if you think the sound that you have record is clear, is okay, you can place the button, and the application will show the result. And the result will show you the level ripeness of this durian, the detail about this durian, and how the number of the day when the durian will be the ripe durian.
For the future plan, take a photo of the stem of durian and add the other type of food such as the coconut, such as the watermelon, and the type of durian. And this is a durian tapping machine. So it's used by the dump pedal principle, and the last set the time to remind you when the durian is live. And this is a SDGs, so it can be connected about our project in the goal number 2, zero hunger, and the goal number 8, decent work and economy goal. And this project, they are precise, easy to use, fast, convenience, expand the business, and reduce the food waste. Because the vendor or the seller, they are planned to durian selling, so it can be better than before. This is a reference. Thank you for your attention.
Wow, okay, good job. And I have 2 questions. Okay, you tell me for future work, you will apply for the coconut and melon or something like that, okay?
Yeah.
Can I use who application apply to gan yao and chini or something like that?
Yeah, you can doing something like that because but they are to collect the data, the new collect data. Yes.
Okay.
Because right now my data set just a Mahjong durian.
Mahjong durian. Okay.
Yes.
And how many data set that you collect for the knocking data?
Right now they are. We are
2,000 right now.
And they are. They are augmentation for increase to right now they are if part the augmentation we are 30,000.
Okay, and I read for your abstract you collect from iOS and Android phones. Yes. What is difference or is the same?
Because we must to collect with iOS and Android because they have different microphone. Yes, we want this application can use for both iOS and Android. So we must to collect the data both.
But for the result, it's the same or it's different?
It's the same.
Okay, and I have questions. If the users knocking the durian different frost, is make it over or not?
No, because we are a lot of data. So when we collect the data, we have a different people to tapping, and they are different effort. They are different distance for tapping. So when we have a lot of data, so I think it's not affect to the result.
Okay, and if the user not actually knocking the durian, but they record some data and they fake it, it can detect or not?
It can detect, but it detect in the cast order. Because the order is mean some of wing, some of car. Because the durian shop in Thailand they are located the roadside, so it have noise about something like car, like wind. Yeah.
Okay, thank you.
Last questions. When you collect knocking sounds for the environment, it has noise or is silent or something?
It have noise. Yes, so the model we have the low pass filter for reduce noise in the model. So it can make us more accuracy.
Okay.
Thank you.
Next, we will proceed to the certification. May I invite Associate Professor Dr. Kisiri Chachiang to give the certification to the student. Please welcome.
Thank you, Princess Chulapon Silent High School Pisinulog, for your innovative and practical project. Your creative use of AI to solve horticultural challenges is impressive. Your work is amazing.
Next team come from Princess Dulaponzana High School student presenting their project titles Caring Plus System to Help Bedridden Patients with AI Hand Tracking. Please join us in welcoming them to the stage and let's make some noise for them.
Hello. Hello.
Yes, my name is Iswan Yuso.
And my name is Napat Isala Silitam. Today we would like to present about our project, Caring Plus System to Help Bedridden Patients with AI Hand Tracking. Do you know what is bedridden patient? Bedridden patient is a patient who need to lay in bed all time. And we are interested in apply AI in medical field. So we choose AI hand tracking because it's easy to use, and having bedridden patient relative ourselves, we have seen it is important to take care bedridden patient all the time. Currently, there are approximately 1 million bedridden patients in Thailand, and this number is expected to continue growing. There are 3 types of bedridden patients. Green group can still move slightly. Yellow group have limited movement in certain area, and the last one, red group, cannot move their body at all. And our system, Caring Plus, only used with green group and yellow group.
Okay, now we looking for working. When bedridden patients raise your hand, the system will, the AI hand tracking will make a gesture on their hand, 21 points, and then a camera will capture the hand and then put to system. A system will change a hand gesture into a message and will send it to a caregiver in line notify. I have example. This example, if I want to, for example, if I am a bedridden patient and and he is my caregiver and I have a back head and he don't stay here, I can use this program for need help to report her. Okay, how to do it? We have 3 main parts. The first part is AI hand tracking. We will use it from media pipes. And second part is made coding for counting number and change it to a command. The third part is set up a ESP8266 board for use with another device. Because I want to show you, we can use with another device not only for send message. Features, this work use AI hand tracking for make it easy, fast, and can useful in real life. It's made for helping bedridden patient who can still move, but can still move a hand.
Benefit is can send notification to caregiver and can simulate to rotate bed in the hospital like that. And this is all. Thank you for attention.
Next Q&A section.
Okay, please go back to your architecture, please. To your work, the main works, the main work is send the notification, right, to the caregiver, and you make additional work to the control the device too,
Yeah.
right?
Yes.
And that means the patient have to show the finger.
Yes.
And if they show
Two
finger,
fingers.
what does it mean?
We put. You can write every what you want. And now we write please help. Yes, two finger is please help. But you can.
We can edit in the letter.
Yes.
We can maybe you have to identify 1, 2, 3, 4, 5 or something.
Yes.
It make more clear.
Yeah.
To translate and apply to the another project. Okay.
Yes.
Something like that. Okay. And if we have two hands and we show one, what kind of
No. Have only one hand.
One hand, yes. But if they show two hands and show one, your work does not.
That's error.
Okay.
Yes.
That's all. Okay.
It means for you have only 5 commands.
Yes. Now it's only 5
only 1,
command.
2, 3, 4.
5. Yes.
And if I do like this.
Yes.
And like this, is the same or not?
It's the same. It's called one finger. Attention is to command. Is
and like this?
It's 2.
It's 2. Or it's only.
Yes. Yeah.
Okay, and then when the patient sends light to is a please help,
yes.
And then send to line notifications.
Yes.
It sent only one time or if the sign or
until you get back.
Until you get back. Or some.
Yeah.
Or maybe for 5 minutes and then for the someone not read and then it send again or not or it's only sends one time.
No, it sends it sends until you get backhand. Do you know?
Get backhand.
Yeah. 1 second is sends one second per one cent.
It's mean when I show like this, it's
yes.
a please help, and then when I finish, okay. And then it's only one time.
Yes. If you do that, it's only one time. But
okay.
if you put it's 10 seconds, it will send it 10 times.
10 seconds.
Yeah.
Wow. A lot. Okay. Thank you.
Okay. Next, we will proceed to certification. May I invite Professor Dr. Gisli Chaojian? Oh, sorry. Sorry. Thank you, Team Pizza Japan San High School student. And like now, we have the halfway point of today's project presentation. Our next team also come from Pizza Japan San High School Pisanulog. They will present their project title, Website for Checking and Diagnosing Diseases Occurring Online Using AI. Let's welcome them to the stage with a big round of applause.
Hi, good morning, everyone. My name is Gilat Poratanapaser. I'm come from Princess Julapon Science High School, Pistonlok. Today, I'm going to present about my project. This is a website for checking and diagnosing disease occurring on rice leaf using AI. This is our introduction. Rice is a crop that is the majority of people consume, and most rice cultivation areas are located in Asia, mostly in India, China, Thailand, and Vietnam. And rice is a key export for Thailand. Proper care is essential. But in present, farmer faces issue with disease affecting rice leaf. So this is the reason why I created a website for detecting disease on rice leaves. And our objective is to develop a system for detecting disease on rice leaf using image processing on the website. And the second, to provide farmers with a website for detecting disease on rice leaves. And this is our process. First step, we must creating and training a data set. First, I will collect the image data of 6 different diseases that occur on leaves. And then I'll collect the data and create a data set from it. And then I train the AI. The second step is front end. I create a website front end using HTML that is attractive and easy to understand. And the second, I create a website connecting using flags to establish an IP server for use with Python. And how to use my website is very, very easy. You must have only 2 things. First is a smart device. For example, you have an iPad, tablet, a PC, or your phone. And second, you must connect it to the internet. So how to identify the disease? First, you can take the photo or capture the image on rice leaf diseases, and then you just upload the photo of rice leaf on the website. After that, the website will output the data like what they can detect on the picture, and they will suggest how to treat them. And this is result will show the increasing training accuracy over the number of epochs, illustrating the model is improving precision with the data set. And the result from training the AI with datasets as indicated by the yellow line show the accuracy here is close to 1, and each disease with a high range, demonstrating that the dataset had a very high level of accuracy, and you can see this line is lost, and that is so low. And this is a result based on a survey from actual farmer, a local farmer, a real person. The left table is show the website usability evolution by 20 farmers. Is aesthetic, speed, problem solving, and accessibility. We have 4, 4.5, 5, and 5 point. And the right table is show the evolution by 20 farmers, like website accuracy, data precision, benefit of use, and easy to use. And the point is 4.5, 5, 4.5, and 5. And both table is based on the survey. It can be concluded that the website is user-friendly and convenient to use. And our advantages, this website can help the farmers stay informed about crops diseases. The sooner they know, that is the faster they can treat. And the second, the platform is convenient, accurate, and suitable for both traditional and modern farmers. And the last is help reduce the cost of purchasing treatment and allows for quicker, higher quality disease management. Thank you.
Please go through your architecture. How many images you collect?
I have, about the data set, I have 10,000 images. Yes.
Collect by yourself or?
Augmentation.
From, collect by yourselves or collect from the
yes,
internet? Or
by myself and internet, both of them.
Both of them. And when you collect the image by yourself, you use the iPhone, you use the tablet, or?
I use a full frame DSLR camera.
What is the solutions? Resolutions of
that camera?
Pardon?
Resolution. I mean.
A resolution?
Yeah,
Oh,
of
it's
the camera.
24 megapixel.
And when you train the data like the high resolution, that the impact on the camera phone or not? Because you use the website and the farmer take a photo with their mobile phone, right? And the resolution of the camera embedded on the mobile phone is not the high. Right?
If the resolution on the farmer's camera is too low, if that means it will give you a low accuracy. Yes.
Okay, thank you.
Okay, good job. How about for data for each class? Is the same or is different? Because you have 6 class, right?
Yes.
Yes.
Here.
This. Yes, you
Yes.
have 6 class.
Yes.
And for the number of data, is the same for each class? Or
It's
is
the same.
different?
It's the same.
It's the same,
Yes.
right?
Every class is the same number of the data.
Okay, and then for this slide, look for the brown spot.
Brown spot here.
Why is lowest accuracy and highest loss?
Because the brown spot, a picture on the right sleeve, is close to some disease that's not in here, like it's an error. Yes, yes, it's code for the others. But in like 2 of the disease, it can easy to, yes, it's very unique. Thank you.
Next, we'll proceed to certifications. May I invite Associate Professor Dr. Kisuri Chorjiang to give a certificate to the students. Thank you, Team Princess Tulaphorn Science High School Pistulo, for that impressive presentations. Your work truly showcasing your innovative thinking. Our next team comes from Princess Tulaphorn Science High School, Phetchaburi. Their project is titled Machine Learning Program to Classify Type of Fossil. Let's give them a warm round welcome to the stage.
Sorry. Is here do you have question came ITL?
Hello.
Hello.
Good
Good morning, everyone. My name is Wongsapat Podamlongchai.
My name is Natita Intabut.
We are from Princess Jurapon Science High School, Peshiburi.
And today we would like to present about machine learning program to classify type of fossil at Khao Nang Phanturat Forest Park, Chaam, Phetchaburi, Thailand.
The present is the key to the past, meaning we can explain the occurrences of things in the past, which serve as key to understanding the evolution of life from the past to the present. Fossils are important resources that help us learn about history and evolution of life, as well as the history of the Earth, including events that occur at various times. Recently, the Department of Mineral Research discovered fossils at Khao Nang Phanturat Forest Park, Chaam, Phetchaburi, a tourist site where visitors without knowledge of paleontology cannot identify the type of fossil. Therefore, the organizers are creating a program to classify the fossil using machine learning.
An objective in order to develop a machine learning program for classifying the type of fossil at Khao Nang Phanturat Forest Park, Chaam, Phetchaburi, Thailand, and to study the efficiency of machine learning program.
And we use Google Colab, Google Science, Hugging Face, and Line official account.
Methodology: 1. Start studying information about programming. 2. Researching information about fossil in Permian era. 3. Correcting fossil images dataset.
4. To create a machine learning program to classify, and we use CNN model to training model. And 5. Create a web application and connect it to Line official account. 6. Set the performance to program.
And result, we will see the graph of loss and accuracy. Conclusion: the web application can classify fossil successfully, distinguishes between kynoid and fuselinid at the preliminary level, and program show that the accuracy by classifying the fossil remain was 0.95, and the accuracy by testing with images of fossil was 66%. Thank you for listening.
Okay. I would like to ask about the data set about your collect the fossil image. How many the images you collect? Because fossil is, I think, difficult to find, right?
Yes, I think so. We have 400 images for 10 model.
400 images for train the model. And what is the algorithm that you use to train the model?
We use CNN for training model.
CNN for.
We have the two class in fossil. One fuselinid and kynoid.
What is the difference of the two classes?
Kynoid is the plant and fuselinid is animal.
Plant and animal, right? And this is most happen in the Khao Nang Phanturat.
Yeah, it's common in Thailand too.
Common in Thailand too. Okay.
Okay, if you watch this fossil, you can separate with your eyes or not? because it's from plants and from animal.
The fossil is small and
The fossil may be different, but I think traveling can separate them because it's very small in the stone.
It's very small, and then when you take a photo, you just zoom like that, or
I think depend on size and stone we made.
okay. And for you have for 400 image and 2 class, right?
yeah.
You speak you how do you know this class number 1, this class number 2 for the expert, or is have something?
We use information of
Department of Mineral Resources.
Oh, okay. It have already that for 400 image. This is for class 1 and class number 2.
Yes.
Oh, it have only this. And for the accuracy, how many for accuracy?
66%.
66. What happened? You use other model because I think it's easy to classify, but for the accuracy only for 60.
Because we have a limitation about light when take a photo and size of stone. Maybe it's very small then.
Maybe if you duplicate image or you change the angle or something like that, it
Yes.
has more.
Yes.
Yes, more image, and then for your accuracy is better.
Yes, we have a lot of remediation.
And it's the same as for accuracy only 60%.
Yes.
Oh, okay. Thank you.
Thank you.
Or maybe change model. Change the model. Yeah.
Okay, next we'll proceed to the certification. Thank you, team Pizza Japan San High School Picture. Our next team let's present Kosen KMITL. They will present their project title, A Cumulative Study of Pathfinding Algorithm with 3D Visualization. With join me in welcoming to the stage.
Test. Okay.
Okay.
So, hello everyone. My name is Anyamani.
And my name is Kritin. We come from Question KMITL.
So today we are going to present about a comprehensive study of pathfinding algorithm with 3D visualizations. First, let me introduce you to our presentation. Okay. So what is pathfinding algorithms? Pathfinding algorithm is an algorithm that finds the directions from the start to the end at the shortest part. It has various applications such as logistic, automators, robot, AI. And in the other hand, there also have many pathfinding algorithms, but today we selected 3 pathfinding algorithms to study. First is A-star, second is depth search, third is breadth search. And we want to compare it as what is the most efficient one, what is the best one. So we use 3D visualizations to visualize it. For the further information, A-star uses special functions as f equals g plus h. G is represent the actual cost to reach node n from the start. H indicates the heuristic estimates of the cost to reach the goal from the node n. A-star algorithm can find the shortest part by using the node that gives the smallest values of h at each step. For objectives of our study, we aim to analyze the efficient stability, space of time, and numbers of thought. Visualize behavior of each algorithm in 3D.
Okay, let's talk about the framework. Our framework, we start to implement algorithm A-star, DFS, and BFS. So after we got the algorithm code, we make a code to generate a mesh. Mesh is defined as a 32 times 32 random map in this project. And we generate this code in the Unity by C#. And next, when we got the mesh and the algorithm, we test our algorithm in the mesh that it's stable or not. And then we make a code to measure the time and path taken. And when we got time and path, we analyze the result and visualize it in the Unity. Next is our flowchart, our program we do. First, it will create a random mesh. Next, it will simulate path, BFS, DFS, A-star, if you select. And next, it will visualize data and the moving. Okay. When we click on, it will random the map, like you see. And then you will have 3 choices to select. First is depth search, breadth search, and A-star. When you click it, you will see the path. The blue one is a breadth search. And it will walk until it reaches its goal. And you can quickly start to click on another algorithm. Red one is a A-star and yellow one is a depth search. And like you see, the one that the longest part is a depth search. And yes, after we simulated, we do the sampling the data like 100 trials, comparison with the number of paths. And we do it. And after we conclude this graph, we got this graph that we comparison between path and the node of 100 sample data. And we see the algorithm that can balance the time and the path well is A-star, the second is BFS, and the last one is DFS. For the conclude, we conclude that A-star is the most efficient and it can balance the accuracy and speed well, and is suitable for the application like robotic, gaming, or the AI navigation. And breadth first is really find the shortest path, and it consume the significant memory, more memories. And breadth first use the least memory, but often produce a longer because it will you do like a sequence or redo many times. And for future research, we extend to analysis dynamic complex environment. And for the application, we need to develop into the navigation, automation system, and logistic terms. Thank you for listening.
Okay, interesting topic. I like it. Okay, for the map, you create auto, or you create manual for the map, 3D map.
Every time that you click on the Unity, it will automate create. It create from the clone one block. Yes, like you have plane and one block will extend to on the plane. Yes, this is after I click one and it will automate generate.
Okay, it means it's changed away, right? And then you told A star is the most efficient.
Yes.
It's for all the map or how many map that you use?
For the graph, this is the conclude from 100 times that I run. 100 trial means I run in 100 maps. So in this graph, it look like seem is equal, but it's not. I'm sorry for the not clearly information. Just you will see like A star part A star is less than BFS and the time a little bit more than BFS. But for we talk to the balance, A star is can do it better. And if we can increase the size of the mesh, like from 32 times 32 to be the bigger, it will show it clearly that A star can do it better.
Why for DFS, depth first search is different?
For the first different, I will take Nampung Sang to explain the algorithm, how algorithm works.
So, sorry, you want to compare these two? Okay, you ask for depth or breadth? Depth first search, right? So the
so far from yes.
Is how the algorithm work? Algorithm work like for 0 is node 1 and 1, 2, 3 is for in order the node. Okay, so that first search means that they will find the first order first, and then they run directly only one node, and then they find the deeply like 1 need to be 2, right? This, and but the 3 they cannot find the part anymore, so they come back to 1 and find 4 again. But even 4 is not, so they come back and go to 2. But in breadth search, in breadth first, it's not. They're like 0, right? And they see 1 and 2. In the time they see 1 and 2, they need to find the second for 1 is 3 and 4, 5 and 6. So they search for all of it together in the same time. So it's used less part.
Yes, but I think you can delete for DFS from your algorithm because it is so far. Yes.
Yes.
And go back the previous slide.
Result slide. Yes.
No, the last one.
The last one. Conclusion.
Yes, that is. And you said that your random you generate the map 100 times, the different 100 times, right? And the map is simple or the difficult map, or you have to classify this kind of the map or not?
For the, I would like to say the when we create the map, it like a just random only. We can classify it easy or not. Some is easy, some is hard.
Yeah. Some is easy, some is hard,
It's
right?
random.
And one more suggestion: if you can identify the map, is one is easy, one is hard, and you can compare a little to make it clear about the A star and BFS. Because actually A star may be suitable for the hard, and BFS may be suitable for the easy one. Something like that. Okay, thank you.
Thanks for your advice. Thank you.
Next, we will proceed to the certification. May I invite Dr. Napat Gyapiban to give a certificate to the students. Thank you, Team Kosen Kim IITL, for such an engaging and well-researched presentations. Your work is truly thought-provoking. Our next team comes from Princess Julapun Science High School, Phetchaburi, presenting their project title, Distinguishing Adults and Children by Analyzing Their Handwriting in Thai Language with Deep Learning. Let's welcome them to the stage.
Hello. Okay, good morning. My name is Nachapong Kampeng from Princess Julapun Science High School, Phetchaburi. So today I will present you about distinguishing adults and children by analyzing their handwriting in Thai language with deep learning. So handwriting forgery can happen in many ways, such as faking signatures in documents or faking signatures on transactions. So checking handwriting is difficult to spot because there are small difference of children's and adults' handwriting. So the new technologies that can spot, like software to detect the handwriting, can help to solve this problem. So I interested in people who age below 19 years old because in this group they need their parents to verify their identity, and people who age 20 years old and above. This method is how to collect the data. I will collect the data by on-site and online to correct the children and adults data sets handwriting. First one is after I collect the data, I need to download to the folder and change the DPI by batch school to compile the folder of data, convert the data folders to 100 multiply 100 DPI by using the batch school to make it low quality. Low quality. And then the data modeling, I will create the deep neural network by using the neural network console based on the ResNet 18. And then create the data set by on the console. Next one is the train model. Execute the program by adjust the image size and change the testing program characteristic. The last one is evaluation and inference by analyze the data. The results and discussion, you can see the learning curve with 74% discrimination rate of Gaukai, because Gaukai is a popular letter in Thailand, so the children and adults can write. So it's hard to separate off between children and adults. And you can see the learning curve of Tho Than is 87% identification rate. So Tho Than is hard to write, and adults and children can easy to separate. Benefit is this model can reduce the fraudulent transaction and homework plagiarisms. To detect the homework plagiarism, and we can follow and track the development of children handwriting and the track of children development. Thank you for your attention.
Okay, good job. I like your topics. Okay, which character in Thai easy and hard to analyze? Which character? Tho Tan Chan is
Tho Than and Tho Phu Thao.
Tho Phu Thao is the best. Tho Tan and Tho Phu Thao is the best to classify.
Yes.
And which character that is confused away?
Is a กอไก่ขอไข่ and คอควาย
กอไก่ขอไข่ and คอควาย Okay. And what is different from adults and the kids when they write, and for the result, what is difference?
The difference is ถอฐาน is the adults sometimes write the ถอฐาน but the children is always write the ถอฐาน and you can easily see the difference from children and adults.
Which one is better?
Children to yes, adult is easy to classify from children.
Okay, please go to the previous slide. So I would like to see the architecture of your work. The last one. To compare, you use two model, right? CNN.
Yes.
CNN and deep learning.
Only CNN.
Only CNNs, right? Please go back to no, the last one. Okay, you use the CNN, right? And you have two type of the data sets, a kid and the adults, right? How many images that you train?
For children is 10,000 data sets, and adults is 10,000 data sets too.
And the same amount in each character, right?
Yes. One people in Thai language we have 44 letters, and one people need to write four times of each one letters.
And for one person's write the 4 times
yes.
of the all character, 44 character,
yes.
And you include the just only alphabet, right?
Only Thai
alphabet, right?
Yes.
Okay, not have the sala, right?
Yes.
Okay, 44, and you collect. How many people that you collect the data?
40 people of each other. 40 people in
40
my
people
school
in
and
school.
for my village.
Okay. Thank you. Okay, and I have to many interest, very interested in this topic, like you use the CNN, you use the LesNet, and you can compare many algorithms that maybe increase your accuracies to
Thank you.
to classify like the กอไก่ขอไข่ขอควาย something like that. Yes.
For the last question, you told me you collect from on site, on the paper,
Yes.
and on the like iPad, right?
Yes.
It's the same for the results.
I collect in on site is on my iPad, and online is I create a Google form and send to the line group
Yeah.
to collect on online.
And then they write on the iPad too.
Yes, and send it to my email.
Okay. Because I think when I write on the iPad, it's not beautiful. Okay, thank you.
Thank you.
We will proceed to certification. Yeah. Okay.
May I invite Associate Professor Dr. Kitis George? Yes.
Thank you, Mr. Japon Science High School Bachelor, for sharing your creative project. And our next team comes from Princess Japon Science High School Buriram. Their project is titled IBIN, Artificial Intelligence to Detect and Spread Touch, Receipt and Image Classification. Please join me in welcoming them to the stage.
Hello everyone. We come from the Princess Jurapon High School Buriram. So we gonna present about the IBIN. Okay.
My name is Thitat Thanomsap.
And my name is Puli Susangwan.
Today we presentation about my project.
Okay.
Before presentation, I have one question. Which bin do you think plastic bag go in?
So, yeah, but okay, I will This plastic bag cannot recycle because you could check the sign in the plastic bag before. Yeah. And
Problem. Problem is a lot of recycle waste is burned because because
so in the normally we eliminate the trash for by the burning or the put in the underground. So the cause come from the we cannot classification the trash. So we're gonna make a solution. Yeah. The next.
solution in problem is I bin or we call it intelligent bin is the smart bin classify trash. Concept of bin bin has concept AI detect and give a reward to user. Objective of bin to facilitate recycling of waste and to study design and create prototype of trash can use spectral as how to use bin. The first log in bin part to display, and second drop
put the trash in the storage, and the third AI will start the cam, and the last process the waste on the convoy belt will move to the correct trash bin. Okay, good. So our hardware we're gonna use the Raspberry Pi 5 RAM 8 GB and use with AI hat for help to process the AI. And the next we're gonna use a webcam. The third we use a motor DC touchscreen model, touchscreen display and servo motor. So model we're gonna use Euro V11 or the version 11 because we use it because the right model and small model to use in the Raspberry Pi. The data set we're gonna use the photo data set 2,524 image. So we're gonna split data to train 20% for valid 20% and test 10%. So it's a process in the coding. The first step we log in inside. We're gonna use the user system for login and sign up. And after login finish, you put trash inside in the machine. AI will detect from this code. So in the picture, we're gonna use the API from the Robo4 because I want to use the live model, because power of the computer. And the next, after the AI detect finish, they will predict the trash you input. So the class of the trash will send to this code. This code used for the control. So the for this code will restrict out the Raspberry Pi pin to control motor. So example, the paper will move to 90 will change to the speed and time to correct position trash bin, to move the trash to correction trash bin. And after finish in the process the trash into a bin, the class of test will go to a reward system. Reward system will move the reward to back to the to a user in the database. So this evaluate model. So the magic confusion, you can see the good model, but if look in the approach and loss curve, you can see it a high learning rate. So we can fix it in the future. This is example modeling. And the impact of our project is save the budget, and the second is reduce the problem, overflowing the garbage, and the last improve the quality of life. The future plan is can use the local model or the cloud model as the optional, and can change the servo motor to the pneumatic air cylinder for the control the door to detect trash in the bin, and the last can modify trash can inside the for the custom area space. Thank you for listening.
Good job. Okay. And how many types of the waste that your system can be detect?
Now we're gonna have the 6 class.
The class 1, what is this?
Six. I'm not sure, 6 or 5. Oh. Oh yeah, in the reward is have the trash, the plastic, paper, cardboard, and grass.
Metal, cardboard, and grass, right? And I have one question. It's a challenge question for you. If I have a paper,
in the side of bottle.
no, if I have the food, right? Yeah. I put in the plastic bag.
Yeah.
What the result of they will detect?
If the plastic bag is transparent, I think it will be move this trash to the trash can, the trash card, because the trash card cannot
detect anything, right?
Yeah.
And if I have a paper button of the milk.
Paper bottle.
Paper button or the milk, and what they can detect? A paper or the trash?
It will be the paper.
But
or a cardboard, maybe.
They have a milk inside.
If have a milk inside.
Yes. You have seen like the paper box of the milk.
Yeah.
Paper box of the milk. It is a challenge.
If the box of milk, the AI will detect the cardboard type, and usually it's so hard because if the real cardboard and the milk point the cardboard, it will the wet and can be.
Maybe depends on your data set and how you to teach.
Yeah.
It is the task or the gas board or something.
The milk box can train the new class in the future.
Okay, please back to previous slide, please.
Yeah.
No, I think for the code, yes, this one. No.
This.
Yes, because I see for test position is have only paper, plastic, metal, and general.
Oh,
what is this?
It's when the AI detect the class, yeah, and they will send to this. If AI detect the paper,
yes,
the paper will command the 90, and 90 will to input this code. So it's a position. Position will in the 90 example, the 90 divide 360 and time the 100 for set speed.
Yes, but I confuse a little bit because for now you have only 4, and then for reward you have for 6.
Yeah, either my fault to cap before I fix the code.
Okay, because if I have class, I don't know what is this. It's view for general, but it's incorrect, right?
Yeah.
Yeah.
So this code I doesn't test now because I test I test the system in the my MacBook. So I doesn't test in the Raspberry Pi now.
Oh, okay. Thank you. Thank you so much.
Thank you.
Okay.
Next, we'll proceed to certifications. May I invite Dr. Napat Galpiban to give a certificate to the students. Thank you to Princess Dulaphonsan High School Buriram for presenting such an innovative and environmentally focused project.
Alright everyone, that's conclude the morning session. It's now time to take a break for lunch.
We hope you enjoyed the presentation so far. This is a great opportunity to relax, recharge, and enjoy a delicious meal.
We will be back to continue with more exciting presentation at 1 p.m. sharp, so make sure you are back in your seats on time.
Take your time, enjoy your meal, and have a restful break. We look forward to see you all back here at 1 p.m.
Enjoy your lunch.
the lunch is from Princess Julapur Science High School, Pisnulok. Their project title is Electric Nose Innovation for Girls. Give a warm round of applause.
Hello everyone. We are students from Princess Julapur Science High School, Pisnulok, Thailand. Today we will talk about our project. This innovation will help customers to buy mangoes on their preference without damaging the fruits. Moreover, from supermarket point of view, they lose 10% to 40% due to the shelf life. Also, as well as contribute to create a modern image, assist in sales planning and build trust with customers. So we try to create and research a new way to measure mango ripeness without damaging the fruits. It's non-destructive way. This is our innovation. It has three main parts of this machine. The fan will exhale the gas out of the chamber. The LCD will show the results after 30 seconds, and the gas sensors will detect the presence of gases. The results will show the majority, the sweetness, and the optimal time for sales. I'll show you how to use this innovation. You just put mango in the hole and waiting for 30 seconds, and the results will show you on LCD. It's countdown 30 to 1. Yes, and then it's analyzed. Its non-destructive analysis, high accuracy, provides sweetness level, ability to predict the ripening time, and also reduce loss over ripening or under ripening.
Hello. At this point, we're gonna talk about the method. Our main task in this work is that we're gonna make the data set and make a model by the algorithms. We have two models in our work. The model 1, we're studying the development of Burkina mango ripeness classification using machine learning based on gases and color. So we're gonna make our own data set by first collect the gas data and color data of the mangoes using gas sensor and RGB sensor. And after that, we'll put the mangoes into the laboratory for the labeling to find its firmness, total soluble solid or the sweetness of the mangoes, and titratable acidity through titration. And after we have that three values, we're gonna put them into this formula. It's an RPI formula which can divide the mango majorities into 4 classes, which is raw, partially ripe, and rotten. And so that we have the gas data, the color data, and the majorities that we have found from the laboratory test, and that's the data set we need. After that, we're gonna put the data set into the Vega program, which is the machine learning program, and train the data set with various algorithms and find the best one to be applied to our box. Now let's see the result of the model 1. Here's the efficiency of the classification model from the various data set. Here's we have tried different data set to be trained in the Vega program. You can see that if we use only gas data as the attribute for the analysis, the accuracy will be 95%. And if we use only color data, the accuracy will be 94%. And if we combine both together, the accuracy will rise up high to 98%. And here's the additional experiment that we have set the sweetness of the mangoes that we have found in the laboratory to be the result of the prediction. You can see that random forest, this algorithm achieved the highest accuracy at 95%. So it is possible that we can predict the mango sweetness through using gases. Okay. End of model 1, we're gonna talk about model 2. This model, we're studying the development of time assessment for ripening of Barracuda mango for sale. We're gonna predict the optimal time for sale of the mangoes. We're gonna collect the data set differently from the model 1. The model 1, we have collect the gas data of the mango and destroy them in the laboratory, right? But at this model, we're not gonna destroy them in the lab anymore, but we're gonna collect the gas data of the mangoes every day till the mangoes are ready for sale. And ready for sale in my definition is that the mango skin is tight and smooth, the color is golden yellow, and the texture is tight but not hard. That's the way of labeling. And after collecting all of the data we have 3 labels, which are the groups of mangoes that are ready for sale in 1 day, 2 days, and 3 days. And once again, put the dataset to Weka program and train them with different algorithms and find the best one to be our model in this machine. Okay, here's the result of the model 2. This algorithm, random forest, achieved the highest accuracy at 85%, followed by random tree and decision tree. So both model 1 and 2, we finally have the result. We're gonna choose the best algorithm to be applied to our box. It obviously the random forest, right? But we eventually choose the random tree because not only the high accuracy enough, we also get the if-else rules or a tree so that we can apply them easily to our coding, so it is easier to apply them to our machine.
Finally, our innovation allies with SDG on Go2 on technology development and also Go12 on reducing food loss. Moreover, in the future, we can expand the market by collecting more data of climate-related fruits such as plum, peach, avocados, apple, or banana because these fruits have same ripening process. Thank you for your listening.
Okay, I have a question for you. Like, first, why you choose the gas sensor and color to identify the sweetness of the mangoes?
Because because gases can tell the mango maturity because it relates to the maturities of the mangoes because during the ripening process of the mangoes, the more the gas will come out more as the time goes by every day, so that we can choose gas.
Okay.
And also the color. Some kind of mangoes, the skin tend to change the color too.
Okay. And you choose gas to measure the sweetness. And how can you test the level of sweetness of the mango? This is the correct from the gas value or not? How you can evaluate the sweetness?
So the sweetness is one of the value that we have labeled. In the process of collecting the data, we collect the gas data and the color data, and I have in the labeling process we have found the sweetness, the tritable acidity, and the firmness, and that 3 values are the label. Yeah, and so that we can choose one of the 3 values to be the results of the prediction.
Okay, it is a sweetness, 3 level of sweetness, and right?
3 values.
3 values, for example.
It has 3 values. This one you can see the formula. Yeah, this formula we use to prediction the ripeness, and we found that we have to mango in the laboratory and found the sweetness in our formula. Yeah, and we label this a formula in label so we can predict the sweetness. Yes.
Okay. I love this topic because I love mango. Okay.
Thank you very much.
Okay, but I want to know what is the possible value for the RPI from what to what? Is the minimum value and maximum value of RPI 0 to 10 or something?
Oh, we're not
For
sure.
range of
We're not
There will
sure
be
about
two to five.
range of RPI is
Yes.
only
Yes. Only 2 to 5.
2 to 5 only this.
Yes.
But it can be 0, right? It's a rotten. RPI less than.
Oh, sorry.
equals zero.
Sorry, my bad. Yeah, it can be the result of the RPI will come out in the real number, and it will transform into the class.
And why I saw for your sweetness is 96%, I think, for previous slides. How do you calculate it?
Oh,
Please, previous slide. Yes.
Next slide.
For sweetness?
For
No,
sweetness.
no.
This one.
the video, right?
That's for LCD. Show the label in.
The video.
Oh, video.
Sorry. Oh,
No.
this one.
Yes, I think for sweetness, 96 something. How do you calculate for the sweetness?
The sweetness that this machine can analyze will be in the percent brick unit.
Percent. Yeah, it's analysis in percent bricks unit.
And the input that we put the mango in, right? And the gas data and color data will be the input, and the input will be analyzed by the algorithms that we have developed.
Okay, and then for the last question, I saw for the abstract, you wait for 1 minute.
Oh, yeah,
to show the results, but for now,
Yes.
you wait only 30 seconds. What
Yeah.
is difference? Is the same or something?
No, we collect the new data of the mango because we want to develop it in new version. Yeah, so that's the 1 minute. I think it's too long for waiting for the result. So we develop it into 30 seconds for its convenient. It's faster and it's better than in the past.
Okay, I understand. It's for the short time, but have you ever compare for 30 seconds and 1 minute for the result is the same or difference?
It's closer. Yeah, but
you can see it
can
in
see.
here. This table is the
version 2,
version
and this
1.
one, it's finally version.
The accuracy is
Closer.
close.
It's close.
Okay. Okay, good job. Thank you.
Thank you very much.
Thank you.
May I invite Professor Dr. Kesi Shasheng to offer the certificate. Okay, and our next team come from Princess Japan Science High School, Pathum Thani. Their project is titled Dr. Love, form for diagnosing diseases appearing on lung believers. Let's welcome them to the stage.
Hello everyone. So let's start. The outbreak of disease in rubber penetration directly impact to latex production, potentially reducing the yield by up to 50%. This outbreak can become more severe, spread widely, and eventually cause the tree to die. For instance, in 2019, in province Narathiwat and Trang, experienced the Peptaloleopsis disease, leaf fall disease that spread across 426 square kilometers, reducing annual production by 93,000 tons. This led to a loss of 423 million baht in income for rubber farmers, a significant amount that they should not have to lose simply due to a lack of knowledge about this disease. And to treating this disease correctly is quite complex and challenging because it requires both of expertise and experience. If rubber farmer didn't diagnose correctly, rubber farmer risk wasting both time and money. So our team aim to improve the quality of life of rubber farmer in all aspects. As we know, AI technology is one of the mega global trend and advancing rapidly. One of ability of AI is that to analyze and progress image with high precision. This inspires us to develop an AI platform to diagnose the disease on rubber tree leaf. We are proud to present an AI platform to diagnose disease that appear on the rubber tree leaf, as we call Dr. Rub.
Okay, so in our development process, we starting by correct the simple image of rubber diseases and then use them to develop the artificial intelligence before integrate into the other platforms. The platform that we use, we call the line application platform, as due to the statistics indicating that this platform is widely by all sectors of Thai population. So in this study, we select 4 types of diseases that appear on the rubber leaf. Firstly, Correctoticum leaf spot. Secondary, powdery mildew. Thirdly, bird eye spot. And lastly, Bacteroideopsis leaf fall diseases. These were identified through information gathered by from the various sources, including books, documents, and research study. So before annotation or make the AI understand the characteristics of diseases, we select 3 of model marked as CNN, Euro V3, and Euro V5. This model have a diagnosing capability and can further to develop into the integration to the other platforms. So in our study, we found that the YOLO V5 model have the highest accuracy from training. That's why we use the YOLO V5. And how do we know that our model can use in real life? So we have to test this. The study of effectiveness of the AI model for diagnosing the diseases. We select 10 picture each diseases. And the study we found that it's over 90% accuracy. That means it's ready to use. So therefore, we further to develop into an API to make it to accessible into the line application to distribute it to the public. This will beneficial for the rubber plantation farmer as they can use our application for free, and it will enhance the convenience and accuracy to diagnosing the rubber tree diseases. Additionally, we found that Dr. Lab can play a role to expanding the market of the rubber tree care products. So our idea is
including a commercial development plan to create an online marketplace to selling this product to our customer. The Lenovo can create it by collecting the transaction fees from both seller and buyer. So thank you to our advisor, Mr. Khun Thong Khai Thong, to give us an advisement, and thank you for RAOT to give us an financial support, and give us a suggestion. Lastly, thank you to the TJSIF to give us a chance to present our innovation to your guys. And this is our reference. Overall, we hope that Dr. Love will be the key part of enabling rubber farmers to sustainably manage their rubber plantation immediately. Thank you.
Thank you.
Okay. Why you choose the 4 type of disease that you can detect?
4 type of disease because these 4 types of disease look quite similar to each other. So farmers have to have a higher skill to classify these 4 diseases. So we use the AI to diagnosing.
Okay, and I would like to suggest one thing, that when you are detect what the result, what the disease that the rubber have, this disease, something like that, and you have to suggest the farmer how to treat them, something like that. And one more thing, that you collect the leaf from the ground, right?
For train the AI,
right.
Or we have from the research that we found and the internet, for even internet image to train the AI.
Okay, and the image from the AI, the laboratory that from what country, you do know?
That from all of the rubber, from all of the
world.
Yeah, no, that's in Thailand.
Yes. Really, okay. If you focus on the laboratory located in the Thailand, okay, it's okay, yeah, because we are in Thailand and we focus the laboratory in Thailand. But if you are stay in the Malaysia or Indonesia, the data set should be changed to train in, depend on the country that you say.
Okay. It might be the future plan to develop more to make it higher efficiency, or it make it to can use in every country. Thank you for your suggestion.
That's good.
Okay, good job. I have 3 questions. Okay, for first, for predict for the disease, for yellow leaf and green leaf, what is difference, or is the same?
It doesn't matter.
It doesn't matter.
Yes,
Okay,
our
good.
AI can classify it.
Okay. Then for this slide, for the data set, is I think you can see for powdery
mildew.
Yes, and for pestaloteopesis, yes, the number is different so much. It's 2 multiplies. Do you do, because it's unbalanced data? Do you do something like a smooth balance for balance data, or not? Or you use only this data?
We don't have the balanced data because we use much as we can to make the AI can classify it high accuracy. It doesn't matter if the powdery mildew have only 1.2K and the pastoral diopsy have 2.3K, but we didn't compare how much. No, we didn't compare each diseases how. ช่วยหน่อยดิภาษาไทยก่อนไม่ก็คือ ข้อมูลมากเท่าไหร่ก็ไม่เกี่ยวอะไรแบบเนี้ย
But I think it's because you can see for the results. Please slide for the result. You see yes. For powdery middle, for accuracy is lowest because it's trained for the low data set. For the number is low or something like that.
Okay, that might be the one reason, but the important reason that the powdery mildew have the lowest accuracy is because of it had a white one. So a way I can classify like it's maybe some light problem or something. So a way I can
Because I think for powdery, it's a yes. No. For next slide, please. Next slide, please. Yes, it's different. It's a unique, but accuracy is lowest.
Yes.
Then I think data is important. For balance data is important. Okay.
Thanks. Thank you. If we find more, I will improve our AI more.
Yeah. Or maybe you can duplicate for data more, but you can change the angle or something like that. Yes. Okay. And for next, for the line application, I like it, but I want for the treatment to the tree or something because for now it's okay. You are and then you don't have for step. Yes, for step for treatment.
That is our future plan to develop to have like suggest how to treat the disease.
Yes. Okay. Good job.
Thank you.
Thank you for your advice.
Next, we will proceed to certifications. May I invite Dr. Napat Pivan to give a certificate to the students. Thank you, Team Princess Tulapur Science High School Pathum Thani for your insight presentations. Your project is both practical and impactful. Our next team represent Nara Women University Secondary School. They will present their project title, Proposal for School Counseling Chatbot Using Fine Tuning. Please join me and welcome them to the stage.
I am Manaka Yashimune from Nara Women's University Secondary High School. My research theme topics is proposed for a school counseling chatbot using fine tuning. There is data that shows that the number of students not attending school in Japan has increased by 1.9 times compared to before the COVID-19 pandemic.
Therefore, I developed the chatbot specialized for school counseling. To begin with, machine learning model run big data to get great results. Hundreds of thousands of pieces of the data are needed, but school counseling don't have the many in their manuals. That teach and currently beginning is called fish learning. There are many teach for future learning, but I am using one that allows you to use a pre-trained model for a similar task. There is a slide mistaken slide, and it says transfer learning, which is a bit different from what I mean. This is also part of future learning. We use GPT-4o in the development. We trained the model on only two manual, both of them are manual for school counseling, published by the Japanese Ministry of Education, Culture, Sports, Science and Technology. There are still some issues to be addressed, so I will briefly explain the psychology aspect below. I encountered research into using a from psychology called the Enneagram to determine the personality of the siren, and they assign a counselor personality that shows a person. The reference is this. This research was conducted as a first year student in the program of development master in information science. I would like to express my gratitude to the teacher who cooperated with me. Thank you for listening.
Okay, hi. Okay. You create for the chatbot.
Yeah.
Right? What is your target group? I mean, only student in Nara University, or I can apply the other university?
No, but I'm going to model is using model.
Using model, but for do you have real application?
Yeah. Yes, but
yes, you have already.
Yeah.
And you test with the student in your university, or it can apply for all Japanese.
No, I'm not using this model and student use now.
Yeah, it's okay. It's okay. What language do you do?
Python.
Python with GP.
Yeah.
Yeah. Something like that. Okay.
Okay, and your when you use the chatbot,
Yeah.
we have to use the Japanese language, right?
Yes.
Okay, and if I use the English language, they can give the response to me or not.
And this is Japanese.
Oh, this just only
Yeah.
Japanese, and to find someone to talk with, right?
Yes.
And or if I have something to tell, and they will respond back to me, give me an advice, right?
Right.
This your applications, right?
Yes.
And application is for just only student in your school.
No.
No, or is it for all in the Japan, right?
Yes.
And do you have an application for the download on the App Store or not? Not now.
No. I am
Okay.
the priority.
Okay.
For that.
Maybe for the next project, maybe you can make an application and publish for the others students to use this application. So thank you.
Thank you.
Thank you, and may I invite Associate Professor Dr. Kesiri Chajiang to offer a certificate. Okay, and our next team comes from Pisachirapan San High School, Pathum Thani. Their project is titled Development of Stellar Image Processing Program for Studying Mangrove Forest Area Using Machine Learning. Let's give them a warm welcome.
Konnichiwa. Hello,
Hello.
everyone. Okay. Mangrove forests is a crucial habitat for the world's ecosystem. They preserve biodiversity, help protect coastal erosions, and combat climate change. However, traditional methods for exploring them can ruin the habitat. There are two ways to solve this, though. One is using drones, but drones are expensive, time-consuming, but they give very accurate results. The second way is using satellite images. They give a huge view, but it doesn't as accurate as the drones. That's why we decided to create our project. Development of the satellite image processing program for studying mangrove areas using machine learning.
Our objectives is to develop a machine learning model that used to classify the mangrove forest area using the satellite imagery and got high accuracy of the results. And we use the tools such as the Google Earth Engine and write with the JavaScript language and use Landsat satellite imagery. First, we need to define the area that we are interested in. In this area is the Samut Songkhram province in Thailand. After we define the area, it will show the result like this. And then we need to create the training data for train the model. We have 4 training data. The first one is the water or blue color. Second is mangrove or green color. Third is building or red color. And the last one is farming or yellow color. But farming is for other type of forest. Yeah. After that, we need to mark the training data down on the area that we define in the first method. Like this, we mark down the water, building area, mangrove, and agricultural area. And then after that, we will let 70% of the mark to be the training data and 30% of the mark to be the testing data. After that, we need to run out the result. And the first result you will see is show high errors. You can observe by the green area or mangrove area with the yellow color or the other type of forest area. it is mixed in the middle of the province, and the green area is spread all around the map. That not the place that mangrove must be lived. So we need to find something that could differentiate the mangrove forest area and other type of forest area. We find a lot of research. Some research said we need to make more training data, like 10,000 data. But I think if we do like that, it's not different from other one. We have some research that use the thing called NDVI, or the leaf reflectance analysis technique, that will measure the length of the light that reflect from the leaf, and they use for detect the plant health. And then we think, how can we use it in another term? We use it as our feature. We input the feature as NDVI into our program, and the result as shown as in the second picture. You can see, compared to the first picture, the green area or the mangrove forest area is only the coastal line. Different from the first one, it shows high accuracy.
Okay, as you can see from the graph, in the top left corner, you can see our graph of the area mangrove forest. The green area is the actual area explored by the Marines, and the blue area is our classified area that our program produces. As you can see, in all of the 3 years, our programs and the area explored by the Marines are all similar to each other. So we decided to calculate our accuracy of our program. As you can see in the graph down here, all of our programs have achieved over 95% accuracy in Samut Songkhram province. So we decided to run in some other years that wasn't explored by the Marines, so we can have data that we're missing. As you can see in the top right graph, it's our graph showing the trend line of our mangrove area prediction. The trend line is going up, which conserves to the many conservation tactics that has happened in the Samut Songkhram province over the years. Then we have our program run the accuracy. As you can see, the zero variable over here, or the mangrove, is over 96% accurate. After knowing that our program is accurate in Samut Songkhram province, we decided to run it in other provinces in Thailand to see how well it does. In this case, we ran it in other 5 provinces in Thailand, such as Samut Sakhon, Chonburi, Rayong, Chantaburi, and Chacheongseao. This results shows the same, where both of the graphs are very similar to each other, which means that our program is accurate. As you can see on the right graph, our program accuracy exceeds 90% in all 5 provinces.
Okay, in conclusion, we can make the model that could differentiate the mangrove forest area or classify the mangrove forest area from a type of forest area with accuracy 90 to 95%, and we can also use in another mangrove forest area that different province that near the Samut Songkhram province. This is our selected reference, and our project would not be complete without the help of advisor. The first one is Mr. Kuntong Klai Thong, Princess Julapon Science High School, Pathum Thani teacher, and the second one is Dr. Sayam Lawa Vilod Wong, Director of Geo Informatics and Space Technology Development Agency of Thailand, Tisda. And finally, I would should thank you for the TJSIF 2024 that give us for chance to presenting our project to everyone. Thank you.
Okay, it's good presentations and I like it. Okay, and please go to how you to collect the data, the satellite image data that you have to classify to.
Okay, to correct first, we need to define the area first, and then we use we collect from the Google Earth that use the Landsat model, the Landsat satellite, and send it onto the web page.
Okay, you the data sets you come from the Landsat, right?
Yeah.
And you okay, and how many data sets that you have?
Okay, we only have for about 250 image because Landsat 8 could travel around the world every 16 days, and it launched from 2013. Yeah. Yeah, yes, the same province.
The same province, right? And when you are extend to the another province, it's the same.
It not the same accuracy. It a little bit dropped down, but it still accurate.
Still accurate. Okay, thank you.
Okay, I think for the mangrove and farming is near similar.
Yes.
How do you to classify this is for the dark green and this is for the light green?
Okay. The thing that we use to classify is not actually color, but okay. But we use the thing called NDVI, or the leaf reflectance analysis. When the sun shines the light on the leaf, a leaf flake out from the leaf, we can measure some range of wave that different plant have different wavelength.
Only wavelength.
Yes.
Okay. Yes. And who is just this color is correct or not? Or you trust for this technique?
This NDVI.
Yeah.
We trust it because we measure from the sensor that have on the Landsat 8 that America launched it out. So it takes for a lot of time. Yeah,
Okay,
a lot of
yes.
time.
Please go to the result page, please. This one, yes. Why for 2017 and 2018? Why for 18 is decrease? Because I think for the mangrove is the same, or yes, why that yes is decrease?
It's decreased because this year there isn't like an actual area explored by the Marines that we can actually calibrate our program with. So this is the variable that our program created, like the area that our program generated, and there might be some error in the year, but the area of error is about 5% in the Samut Songkhram province.
10 to 5%, 5 to 10%.
Yes, because I think it has some error because mangrove is mangrove.
Yes.
You cannot do something in there. Okay,
Yes.
thank you so much.
Thank you.
Thank you.
Next, we'll proceed to the certifications. May I invite Dr. Napat Gyalpiban to give a certificate to the students. Thank you, team Princess Julapron Science High School, Pathum Thani, for presenting such an innovative and environmentally conscious project. Our next team comes from Princess Julapron Science High School, Pisnulok, presenting their project titled Development of AI-based concealed gun detection and notification system. Please join and welcome them.
Hello everybody. My name is Pathfinding from Princess Julapon Science High School, Pisnolok. Today I'm going to present about my project, the development of AI-based gun detection and notification system. Firstly, I'll begin by the introduction of the project. Nowadays, there's a lot of mass shooting incident in another country like USA, like Thailand, and it's record the loss of life and the property. As you see in this graph, the first paragraph in the left side is the number of mass shooting in the United States between 1982 and the September of 2024. In the 2023, it had